Hello Pre-Calc kids, welcome back to another lesson in AP Precalculus. This is Mr. Bean, and today's lesson we're going to look at this thing called planar motion when we're dealing with parametric functions, and how parametric functions actually show us the motion of a particle on a two-dimensional space. So to start us off, let's just remind ourselves real quick some of the things we talked about in the last lesson, which is that a parametric function has this x function and a y function, like different components for the x and the y's. And what that does is that tells us when an object was at a place, not just that it was there, but we can actually use the variable t, the parameter, and know when that happened. So we're going to do a couple things today, including using a calculator. So you will need to have a calculator for today's lesson because we're going to practice some stuff there, graphing calculator, I should say. So we're going to look at this first one, t cubed minus 4t for the x value, and then the y value is going to be 3t. Now we will have a restricted domain from -2 to 2. And I've already set up a table for you, so we don't need to figure out all the x's and y's. That's done for you. So here's parameters. So what we need to do is just graph these coordinate points. So just as a reminder, if we're going to graph this stuff, this would be our first coordinate point, 0, -6. So we just grab our grid over here, 0, 1, 2, 3, 4, 5, 6, put our dot, and then why don't you go ahead and pause the video now, plot these other coordinate points, and let's see what you get. And hopefully you got something that looks like this. Now, I did not connect them on purpose yet because I wanted to demonstrate that we don't know for sure exactly what this looks like. We would have to get more coordinate points, meaning we would have to plug in maybe some t values in between -1 and -2 and in between 0 and -1 if we wanted to know how the curve looks, if it's a straight line or whatever. See, because right now, if we just connect these, it would just be some straight lines like that. Just some different segments, and then that would be it. That might be what it looks like, but we don't know without more coordinate points. We'll do that in just a second. I'm going to show you something. This part here, I just wanted to see if we said, what if t equals 10? Now, that's outside the restriction, right? We were restricting between -2 and +2. 10 is past 2, so we're saying if there was no restriction, where would the particle be? So that's just to make sure you understand that just means you're plugging in a 10 to f of 10. Oops, that's really messy. And so then that would equal 10 cubed, which is a really big number, 4 times 10, that's the y value. And then the x value would be 3 times 10. And then you simplify from there. What is that? 10, 100, 1,000? 1,000 minus 40. And then here's 30. So then the final answer is that the coordinate point at t equals 10 would be at 960, 30. That's where the coordinate point would be. Okay, so now we're going to grab a calculator. So if you have a graphing calculator, please grab that. Mine is a TI-84. Let me get rid of this. There we go. So my TI-84, I'm going to show you how to do this. If you have a different type of calculator, it doesn't have to be TI-84, that's fine, but you're going to have to look up how to use parametric functions with that calculator. You can Google it, look up in the user's manual, but you'll need to know how to do that with your personal calculator. All right, so for mine, I'm going to go to the mode here, click on mode, and you notice if we scroll down here, one option is function. That's what we're used to doing. Then there's parametric, that's what we want. And then polar, that's with Mr. Brust taught us some polar stuff. So we're going to do parametrics, make sure that is highlighted, that you change your mode of your calculator to parametric mode. And then if I go to y equals, you can see here what your x component and what your y component is. So let's go ahead and plug in this t cubed minus 4t. So how do you get the t to show up? The t is just the variable button. See here where it says x, t, theta, n? It changes based on what mode you're in. So that's if we're in function mode, parametric mode, polar mode, sequences, I think is what that last one was. So let's just plug in, hit the variable button, and boom, it shows a t instead of the regular x. So t cubed minus, what am I doing? 4t. There's my, I forgot the minus. There we go. And then what we want for the y, 3t. Okay, so now before we hit graph, let's look at the window. The window is important. So the t-min and the t-max, that would be where our restricted parameter is. So we're going to go from -2, so do -2 to +2 for our parameter. Now the t-step, I'm going to change this to a 1 just to demonstrate something. This t-step is how often we're plotting a point. So if I wanted it to look just like my table, my table increased, let me show you here. My table increased by t-values of 1. It went from -2, -1, 0, 1, 2. So on the calculator, that's how I would represent exactly what my table looks like. Now the x and the y min, that's just how far left, how far right we want to go. So if I made it go to -10, then it would be just like our graph here that we have on the notes. And then the y min, I could do -10 as well to +10. Okay, now let's graph it. Okay, that is not what we want it to look like. So it's straight lines like what I said, but the problem is it's because of my t-step. So if I go back and look at this, the t-step was a 1. It's only plotting the points every t-value of 1, and then it just connects them. So what if we did, let's go to window, what if we did a t-step of 0.5? So every half. Let's graph it now. Okay, still, that looks a little bit better. So every half of a t-value, it's plotting a point and connecting it. So you've got multiple straight lines, straight lines, straight lines. So how about if we do 0.1, if I can type correctly, 0.1, enter, and graph that. Okay, that looks better. So you can see we're starting to get a curve here. So let's go ahead and connect that on our graph. We know it's supposed to be a curve, and we get something like that. And then I just want to demonstrate one more thing on the calculator that's kind of cool. So what if we did a t-step, instead of 0.1, what if we do 0.001? So that's going to take a lot of tiny little t values and connect them all. Well, the reason I want to show you this is watch what the calculator does. If I graph it, it's slowly it's putting all these little tick marks and then connecting a straight line, really tiny straight lines. And now it's a nice, really smooth graph. Okay, so that's just what the t-step does. If you wanted to see the actual motion, you would do a really small t-step, and then you could be able to see it slowly connecting. Now, the last thing is we're going to put on here some arrows. So I don't think I did this in the last lesson. I think I did them off the side. Sorry about that. Let's do it right, just like this. So we do some arrows to demonstrate that this is the direction we're headed. Because it is planar motion, the direction matters for this. We started down here and we ended up here. You're going to use the calculator today to check your work, but not to actually do the work, if that makes sense. So on the assessment, you're not going to use the calculator on this, but it's great practice to look and see, are you doing things correctly or not? All right, let's move on. Next up, we're talking about extrema on the horizontal and extrema on the vertical. So in other words, how far left, excuse me, how far left and right it is. So this right here, horizontal, we're just talking about what's the furthest left it goes and what's the furthest right it goes when we're talking about the horizontal extrema. And then for the vertical extrema, that would be how far down? Yeah, down, bottom, I don't know what you would say. The bottom of the graph, or how far down it is, and then how high it is, the top of the graph for the y values. So that vertical is up and down. So the horizontal extrema of f of t is going to occur when we have maximum and minimum values of x of t, right? So x of t is maximum minimums, that'll tell us. So a minimum of x of t is going to be the left side of the graph. The maximum of x of t will be the right side of the graph. And then same with vertical, it's just the same idea. We take the vertical extreme of f of t is going to happen when we have a minimum of y of t, a maximum of y of t. For the bottom of the graph, the top of the graph. Smallest y value, largest y value. All right, so let's practice that real quick here. Determine the horizontal extrema. So now here we are on a restricted domain of -2 to 5. Okay, so let's look first at the x of t for the horizontal extrema. This is saying this here, 1 minus t. If you ignored everything else and you weren't worrying about what f of t looks like, just think what it would be 1 minus t. That's like a line, right? 1 minus t with a negative slope, it would be a line like this with a slope of -1. So that means at -2, so let's plug in the end point here at -2. That gives us 1 minus -2, which equals 3. So that value would be a maximum. We know that because it's a line. And then let's plug in the other endpoint just for the practice of this. X of, what am I saying here? X of 5. So we'll do the right side. And that is going to be 1 minus 5, which equals -4. So we can see here, this is a maximum value. This is a minimum value. Now I'm going to get rid of this line here because that might be confusing you. That line is not what f of t looks like. Okay, that's not f of t. We'll show you what f of t is here in just a minute. So what we're going to say is, since that's a maximum, we're going to say what are we doing? Horizontal? So horizontal max of 3 at a t value of -2. Okay, so we have a horizontal maximum of 3 at a t value of -2. So when t equals -2, this graph, this f of t graph, is furthest to the right. And then we have a horizontal minimum of -4 at t equals, and then what's the t value to get this -4? It was a 5. Okay, so that's what we do to say where we have our max and min. We say the max and min value, which in this case is 3 and 4, or -4, and then where does it happen? At the t value, the parameter value of -2 and 5. All right, so let's do the vertical extrema. So now we're doing the same idea, but this time we're doing t squared minus 1. I'm going to go ahead and do the coordinate points, but I'm going to show you something after I do that. So let's go ahead and do the endpoints first. So x of -2, that's going to be -2 squared is 4, so 4 minus 1, that equals 3. And then we get the x of 5 for the other coordinate point. 5 squared is 25 minus 1 is 24. So you might initially just think, oh, well, okay, so this is a minimum of 3 and a maximum of 24. But that's not right, because you have to think about what is this t squared minus 1 doing? Okay, not what is f of t doing, just the y component. Well, think about that. T squared minus 1, if you think back to your algebra days where we learned about parabolas, t squared minus 1 is just a parabola that's shifted down 1, right? If we just had it would be like this, where the parabola is just shifted down 1. So what's the minimum value? That minimum is -1. So we know that if t is a 0, if we said, oh, I said x here. Some of you were screaming at me when I was doing that video. Let me fix that. Sorry. Okay, y. Yeah, that was a mistake. Y of -2, y of 5. I was plugging in the y value. Darn it. I hate making those mistakes. Okay, so let's get back to this. So the y value then of this thing, we're going to say if we were to plug in a y of 0, we would get a -1. See, that coordinate point, that t value of being a negative, or excuse me, of being a 0, gives us a smaller value than this 3. So sometimes you have to just use your knowledge for this of knowing where the min or max would be of the graph, and then also check the endpoints. Okay, so let's do this then here. The maximum is 3, so we'll say a vertical maximum of 24, because 24 is the largest, right? So 3, 24, -1, 24 was the largest one. Vertical max of 24 at the value of the parameter t equals 5, right? So when with t is 5, we get a max of 24. And then what was the minimum? Vertical min of -1 at t equals 0. That's when it happens. All right, so that's how we determine the horizontal and vertical extrema. So let's check our results. So if you flip your page over on your notes, you're going to see a graph that represents this thing. So this is the graph, and let's just see if we did this right. Well, what was the the horizontal? What was the horizontal max? Horizontal max was 3. So what is the graph? What's the furthest to the right it goes? The furthest to the right is a value of 3. And then if we go back here, what is the horizontal min? Horizontal min is -4. The furthest to the left is an x value of -4. Perfect. Okay, let's check the vertical. Vertical max, the highest is 24, the lowest is -1. So the highest the graph goes is 24. The lowest the graph goes for y value is -1. So that worked out perfectly for us. Okay, that's how we do vertical max and mins. But what if we didn't have a domain restriction? So there's sometimes situations where it doesn't say that we've got a little that the t value has a restriction on it for the parameter. So let's take a look at this one. Determine the horizontal extrema. This one's going to be actually really easy, because we're just saying for this x value, think about this, the t minus 1, since it is a line, and a line is going to go on forever up and down, and so the horizontal extrema for this is that there are no extrema. X of t is linear, so there are no extrema. And if you look at y of t, it's the same thing. T over 2 is like 1/2 t plus 1. That's also linear. So we'd say that y of t is linear, so there are no extrema. Okay, so I put this graph here so that we could just check and see what does the graph look like. So just for the practice of it, let's just grab our calculator. And I'll go to y equals. Let's plug in this first one real quick and the y component. We graph it, and oh, that's going really slow. Let's change the t-step. We'll go 0.1. Now, if I graph this, I'm only going to see a little tiny portion of it, but that's because my window for my t-values was only -2 to 2. So if I go much larger, like -10 to 10, we're going to see a lot more of the graph. -10 to 10, and then we graph that. Yeah, there we go. Okay, so it's just a line that goes straight across like that. If we wanted to be more exact, we could plug in some coordinate points like t equals -1, t equals 0, t equals 1. That's probably enough because we know it's going to be a straight line. And then from there, we can figure out the coordinate point. So -1 minus 1 is -2. -1/2 plus 1 is 1/2. The 0, if I plug in a 0, I'm going to get a -1. And then here is also a +1. And since we know it's a straight line, that's all we needed was 2 points. So we checked it on the calculator. But then let's just do this one too. 1 minus 1 is 0. And then plug in the 1 there. 1/2 plus 1 is going to be 3/2 or 1.5. So that's plug points in. -1, 1, 0, 1.5. So then you can see here, that's what the line's going to look like. And it's got arrows on both ends of it. Okay, next one. Horizontal extrema for this one. So this one, again, it doesn't say specifically that it has any restrictions on the domain, but this one's a little trickier because you have to recognize that there is actually a restriction on the y component. The t plus 1 has to be greater than or equal to 0 because you can't have a negative underneath the radical. Or in other words, t has to be greater than or equal to -1. So we have an endpoint here. The endpoint is -1, and then it goes on forever and ever. So let's plug in the -1, x of t, -1 into the t value of the x value. So that's going to equal -1 plus 3, which equals 2. So we have either a min or a max at this for the horizontal extrema. Which is it? Well, you just have to think about what t plus 3 is. It's getting larger and larger and larger as the t values move to the right. Taking 3 and we're adding on the t value each time. So that means this is a minimum. So we'd say a horizontal min value of 2. So the min value is 2 at a t value of -1. All right, next, how about the vertical extrema? So for the vertical extrema, we're just focusing in on just the y, and we have a endpoint at -1. So let's plug in the y of -1, and that's going to give us a 0. So now just think about what that graph looks like, the square root graph. Remember this? Square root graph looks like that. So all we've done is shifted it left 1, and therefore that is a minimum value. So we have a vertical, I'll abbreviate here, vertical min of 0 at t equals -1. All right, and then from there, let's use the calculator just to help us figure out what the sketch of this looks like. So there's things entered in here. There's the x and the y coordinate point and functions. And then if we graph it, it looks like this. So you can kind of see it. Basically, it's just like the square root graph, but it's starting right there at the coordinate point of -2, 0, which makes sense because we said there was a horizontal min of 2 and a vertical min of 0. So we're starting off right there. And we could plug in some more t values if we wanted to get more exact, but I'm just doing a quick little sketch to show us what it looked like, just to see the vertical min and the horizontal min. Okay, that was a lot for this. Last thing we got to look at is the x and y intercepts. This is actually pretty quick and easy. So the x and y intercepts, all we do here is let's just remind ourselves real quick. If I have some random graph and I said, like I was having this type of graph like that, I'll make the arrows go down here. Then that coordinate point right here, that coordinate point is some x value, 0. I don't know for sure what that x value is, but I know for sure the y has to be a 0. And then this one right here, that is some, it's 0, some y value. So I know that to be true. I don't know what the y value is, but I know the x has to be 0 for a y-intercept. And that's where this comes from. The x-intercept is going to occur at t values that force the y to be a 0. So we get an x-intercept if the y is a 0. And then down here, we get a y-intercept if the x is a 0. So the x on that one had to be 0 for that to work out. So all we're doing now is we're just going to say, well, if I want to know what the x and y intercepts are, so let's start off with x-intercepts. If I want to know what the x-intercept is, I need to say that the y value has to equal 0. So I take the y value here, which is t plus 4, and I say t plus 4 has to equal 0. I solve that, I get t equals -4. So we have an x-intercept at a t equals -4. Let's plug that into our -4 in. What do we get here? So -4 squared is 16. Plus 5 times -4, that's -20, plus 6, comma, and then I already know the y value has to be a 0 for the x-intercept. And if we plug in the -4, you'll see that. And then you just clean this up a little bit. So the x-intercept is at, whatever that is, 2, comma 0. That is our x-intercept for this graph. And we didn't even have to graph the whole thing out to find that. We just know by using the algebra. All right, let's do the y-intercepts. So the y-intercept is going to be when the x function, the x component, equals 0. Well, in this case, that is this right here, t squared plus 5t plus 6. So if we say that that equals 0, there we go. Now, how do we solve that? You could use a quadratic formula if you want, but that's not necessary because this one factors nice and neat. It factors to t plus 3 times t plus 2. That equals 0. You solve each piece of those and we get t equals -3, or we get t equals -2. So we have 2 t values for y-intercepts. So we take each of these and we plug them in. Now we already know if it's a y-intercept that the first coordinate point is going to be 0, right, for a y-intercept. And you could verify that. Plug the -3 in here. You're going to get a 0 if you plug that in. So 0, comma, -3 plus 4 is 1. So there's one of my y-intercepts. My other y-intercept is going to be 0, comma, plug in the -2. -2 plus 4 is a 2. So there's the y-intercepts. There's the x-intercept. Now let's just graph it and verify our results. See if we did it right. All right, entered them in. Let's graph it and see. All right, so it's kind of hard to tell here, but if we zoomed in, if I change my window and zoomed into this, I'm going to change my x-min and y-min values -3 to +3 on both of those. Graph that, and now you can see a lot better here. We see we have a 2, 0 as the, wasn't that right? 2, 0? Yes, 2, 0 as my x-intercept, and my y-intercept is 0, 1 and 0, 2. So that was perfect for this. All right, that's it for planar motion. This is Mr. Bean signing off. Rock that master check, and I'll see you back in the next lesson.